Okay, tonight's presentation is Just Say No to Useless Maintenance, presented by Mike Bush of Savvy Aircraft Maintenance Management. For those of you that are unfamiliar with Mike, he is a regular columnist for Sport Aviation magazine. Does an excellent feature each month, a must-read in the magazine. He was the National Aviation Maintenance Technician of the Year in 2008. Little known fact is he was one of the co-founders of AvWeb. But more importantly for tonight's presentation, he's an airframe and power plant mechanic with his inspection authorization and has lots of time flying behind and working on piston aircraft. So Mike, welcome aboard tonight, and let me go ahead and turn the screen over to you. Thanks for doing this tonight, Mike. Oh, Mike, I think I have you muted. Hold on one second. Give me 1 second, and I have you live now, so you are with us.
There you go. There you go.
Welcome aboard.
Very good, Charlie. I take it you can see my screen now and hear me okay?
Everything sounds great and looks great.
Okay, cool. Last time we did this, we had a few little bandwidth issues. I've figured out some tricks, hopefully, to solve that problem this time. But if we run into any problems, please jump in and let me know. Good evening, everybody. Wow, it looked like we had something over 200 people in the room, which is wonderful. And my name is Mike Bush, as Charlie indicated, and you hopefully have been reading my monthly Savvy Aviator columns in EAA Sport Aviation. And I am also president of a company called Savvy Aircraft Maintenance Management, Inc., and we manage maintenance for owners of owner-flown aircraft. And the main reason that I mention that is because we manage lots and lots of annual inspections. In the last 3 years or so, we've managed about 450 annual inspections, and we've seen just about everything that can happen in an annual: good, bad, and ugly. And so what I'm going to be talking about tonight is some of the techniques that we use in managing annual inspections to try to save our clients money. And we tend to save them lots and lots of money, mostly by avoiding maintenance that isn't necessary, isn't required, and is not particularly beneficial. I've estimated that probably half the money that most aircraft owners spend on maintenance is wasted. And when I say wasted, I mean it's spent on things, on work that does not improve the safety or dispatch reliability of the aircraft and is not required by regulation. And if we're doing work on our aircraft that doesn't make them safer, doesn't make them more reliable, and isn't required by the FAA, then we're sort of tossing money down the toilet, at least in my view. And so one of our main objectives when we're managing maintenance is to try to avoid doing that sort of stuff. My company deals strictly with certificated aircraft, and not quite 2/3 of the aircraft we manage are Cirruses. We manage a lot of Cessnas, a fair amount of Beechcraft, and kind of a gaggle of other stuff, but they're all certificated aircraft. And tonight's webinar will be dedicated to the story of one of our clients, a fellow by the name of Allan, who had sort of an eye-opening experience on an annual, and I'm going to kind of walk through it with you because there are a lot of lessons learned from Allan's experience. Allan owns a 2003 model Cirrus SR-22. He bought it new in 2003, so he's owned it for about 8 years, and in that 8 years he's put on almost 1,900, probably by now it's probably over 1,900 hours of total time. He flies a lot for an owner-flown aircraft. In fact, he commutes to work most days. He lives and works in cities that are about an hour's flying time apart and an unreasonable distance apart driving time, and so he flies to work he commutes in his Cirrus and puts a lot of hours on them. And for most of the time that he owned this airplane, he was using a service center near his office as opposed to near his home. And after the warranty on the airplane expired, he found that he was spending on the order of $5,000 each annual, plus or minus, obviously, depending on what came up. But that was the order of magnitude. For his 2010 annual, however, he decided to try a different service center, a service center that was located near his home as opposed to near his office. He put the airplane in this service center that he'd never used before. He got on a 747 and flew to India, where he had a 2-week business trip. And about a week into his trip to India, he receives an email from the service center that really got his attention. It was a long multi-page estimate, repair estimate, containing 89 discrepancies, and the bottom line on that estimate really got his attention because it wound up being very nearly $25,000 combined parts and labor, about half and half, about $12,000 worth of parts and about $12,000 worth of labor. This was something like 5 times what he had ever seen before on an annual inspection. And here he is half a world away, sort of panicking. And at that point, he called me and asked whether my company could help him out. Now, as a general rule, we don't usually accept new clients halfway through an annual because these things tend to be very difficult to deal with. And normally, we ask our clients if they're going to sign up for our managed maintenance program to sign up a couple of months at least before their annual inspection starts so that we can get properly prepared. However, Allan's situation was so extraordinary, and he caught me at a moment where I was a little bit soft-hearted, and so we, after some discussion, decided that we would take him on in the middle of this annual and see if we couldn't help him deal with it a little better. So the first thing we did is ask Allan to send us the estimate that he'd received from the shop, this wonderful $25,000 estimate. And we started going through it in detail to figure out, how this annual could possibly have been estimated at $25,000. And I'd seen some fairly high annuals on Cirruses before, $10,000, maybe a little over that. But frankly, I'd never seen anything even close to this one. So we started through the estimate that the shop provided, and it started out with an annual inspection flat rate of $3,645, which was a little on the high side, but when we investigated further to find out what the shop included in that flat rate, we felt it was within tolerance and that it was an acceptable quote. We then started going through the various discrepancies and repair estimates. And I'll just kind of run through these with you really quickly just so you get an idea of what this owner was looking at. The Cirrus annual inspection checklist includes a whole bunch of 5-year items. Calls for replacement of flexible fluid hoses, flammable fluid hoses, fuel and oil hoses. That was estimated at $1,900 parts and labor. Replacement of fuel drain valve seals, estimated at $180, and gascolator seals, estimated at $150. Replacement of the aileron rudder interconnect shock cord, $160. They recommend exchanging or overhauling the alternator at the number 1 alternator, the primary alternator for the airplane at $500, $1,440. The number 2 alternator, the backup standby alternator, at 1,700 hours, and this airplane was up over 1,800, $790 to overhaul that. The propeller is a Hartzell propeller, and Hartzell recommends overhauling that propeller every 6 years or 1,800 hours, whichever comes first. That was a $3,720 charge. Magnetos, TCM has instructions for continuing airworthiness, calling for overhauling of both magnetos every 4 calendar years, $1,700. Cirrus recommends replacing the main battery every 2 years. Recommends replacing the TKS anti-ice filter every 2 years, $320. Fuel injector nozzle cleaning annually, $200. The shop reported that the rubber boots on the prop that's part of the TKS system, these are not heated boots or anything, that they're just rubber boots that have ribs on them to direct the TKS fluid. And the shop indicated that these were cracking and should be replaced, $860. They reported that the lower cowling, which is a composite cowling, was exhibiting significant heat damage, and that it needed to be repaired, estimated at $940. Wing root fairing caps disbonding. That's a fairing at the wing root that's held on by double-sided tape, and it was starting to come off. They estimated $950 to replace those. Flame cones in the mufflers were warped, and so they estimated $2,280 for 2 new mufflers. They recommended that the 121.5 ELT be replaced with a 406 megahertz ELT, estimated $750 for that. Bunch of little cosmetic items, touch-up paint in various places that totaled $1,620. And then about 50 additional minor squawks, just a whole bunch of little things that totaled $1,425, coming to a total estimate parts and labor of $24,730, almost $25,000. So, what do we do about something like this? Well, what we have to do is we have to go through all of these discrepancies and evaluate which ones are worth repairing and which ones aren't. And of the ones that are worth repairing, whether the method that the shop is proposing to repair them is the most cost-effective, or whether there are more cost-effective alternatives. So in essence, what we need to do is go through this thing and decide what we're going to say no to. And over the years, we've become pretty expert on what to say no to. And before I go through and explain to you what we said no to and why, let me talk a little bit about our philosophy of maintenance and how we make these decisions about what to say no to and what to say yes to. We have a reliability-centered maintenance philosophy, and I'll talk about that a little bit at the end, because I've written some articles for EAA Sport Aviation you might want to review if you haven't read them already. But the reliability-centered maintenance philosophy is one that says maintenance is not an inherently good thing. It is a necessary evil. We treat it a lot like surgery. Sometimes we have to do it, but we certainly don't want to do more maintenance than necessary. You don't get extra credit for doing maintenance above what it takes to make the airplane safe and reliable and compliant with the regulations. And one of the things that there has been a tremendous amount of research on is the fact that more maintenance is not necessarily better. And there were studies back in World War II, and there were some very in-depth studies by the airlines in the 60s that showed beyond a shadow of a doubt that doing more maintenance than necessary actually makes the airplane less reliable. Not only is it a waste of money, but it actually hurts more than it helps. And the reason for that is that every time you commit maintenance on an aircraft, you run the risk of breaking something. This shouldn't be a shock for anybody that owns an airplane. Everybody that owns an airplane has had the experience of putting the airplane in the shop for an oil change or an annual inspection or whatever, and getting the airplane back out of the shop and discovering that something that worked perfectly fine before isn't working anymore. We call that a maintenance-induced failure, and it's one of the banes of maintenance, that anytime you take something apart, you run the risk of breaking it. And so if we can avoid taking things apart that don't need to be taken apart, we are going to have a more reliable airplane. And that's what all of the research has shown very dramatically. Now, most shops follow the manufacturer's recommendations. In the case of this Cirrus publishes a big long list of recommended maintenance items, like all those 5-year items we were talking about, and the 500-hour alternator replacement, and so on. But in most cases, those recommendations are simply recommendations, not requirements. There are very few cases where, and we'll talk about those, where manufacturers' maintenance guidance is actually required. But in most cases, it's not. In most cases, they are mere suggestions that the owner can accept or decline at his discretion. Manufacturers' recommendations are often excessive and costly, and sometimes they're actually detrimental to the reliability of the aircraft. So we are very, very careful about scrutinizing manufacturer-recommended maintenance, in this case, Cirrus recommended maintenance, and saying yes to the stuff that makes sense and saying no to the stuff that doesn't make sense. And the FAA gives us that latitude. We are not required to maintain the aircraft according to the manufacturer's recommended maintenance program. Now, if you're a Part 135 operator or an airline, it's a different situation. But if you're a Part 91 non-commercial operator with an N-registered aircraft, so that we're working under FAA rules, we have very, very wide discretion as to what we can do and what we can decline. Now, you need to understand that if left to their own devices, mechanics will almost always maintain the aircraft according to the manufacturer's recommendations. And the reason that they do that is because if the manufacturer recommends a maintenance item and they don't do it, and then something goes wrong, they are liable. They have liability for civil liability for negligence. It's not that they're violating an FAA regulation. It's that owners frequently wind up suing mechanics and shops, and the mechanics and shops are very concerned about that. There has been a huge explosion in litigation against mechanics and shops since 1994, when the General Aviation Revitalization Act was passed. Prior to that, it was very unusual for a mechanic or shop to be sued. The conventional wisdom was the deep pockets are the aircraft manufacturers, and so if there's an accident, you sue the aircraft manufacturer. In 1994, Congress passed GARA, which effectively put a statute of limitations, it's called a statute of repose, on aircraft manufacturers' liability. And it basically said once an aircraft becomes 18 years old, the manufacturer is off the hook for product liability. So you can't sue the manufacturer if the aircraft is more than 18 years old. And of course, the vast majority of the GA fleet is over 18 years old. My airplane's a 79. It's it's more than 30 years old. So That didn't make the lawsuits go away. What it did was redirect them, since you can't sue the manufacturer anymore if your airplane's over 18 years old. Everybody else who touches the airplane winds up getting sued, and in particular, shops and mechanics get sued a lot. So shops and mechanics have gotten very, very, very liability conscious and very gun shy. And so if left to their own devices, they will always do things the way the manufacturer recommends. And if you don't want the airplane maintained in accordance with manufacturer recommendations, you need to tell them no. If you tell your mechanic you do not want a recommended item to be done, let's say replacing the alternator at 500 hours, and you do it in writing, that takes the mechanic off the hook. Because then, if there's a lawsuit, he has a get-out-of-jail-free card that it says, it wasn't my decision not to do the alternator. I recommended it, and the owner declined it. So that takes the liability off the mechanic and puts it onto you, where, in my view, it belongs. Owners are supposed to make the decisions about how their airplanes are maintained, not mechanics. And again, if you let a mechanic make the decisions for you, those decisions will be what's in the mechanic's best interest rather than necessarily what's in your best interest. And as I said, there's this tremendous concern about liability these days that cause mechanics to make much, much, much more conservative decisions than they did, say, 15 years ago, before this big explosion of lawsuits. So anyhow, the trick to keeping maintenance costs under control is knowing when to say no and knowing what to say no to. And that's really what we're going to be talking about for the rest of this webinar. So let's talk about good candidates for saying no to. Probably the prime candidate of stuff that you should consider saying no to are manufacturers' maintenance intervals, like the 5 years and the 500 hours and stuff like that, that really could be performed on condition instead. On condition means that instead of replacing or overhauling a component at a particular time, you inspect it and replace it or overhaul it only when the inspection indicates that the component has deteriorated and that it needs replacing. Condition-based maintenance is always vastly more cost-efficient than time-directed maintenance, because condition-based maintenance means that you're doing maintenance only when it's demonstrably necessary. Time-directed maintenance is maintenance that's done on a fixed timetable, whether it needs to be done or not. Furthermore, the time-directed maintenance that manufacturers recommend are all calibrated to the worst-case airplane. If they say that they want you to do something every 500 hours, it's because that 500-hour recommendation has to work for every airplane in the fleet, even the worst-case airplane, even the airplane that is tied down outdoors instead of being hangared, that is only flown once a month, that lives in South Florida where the atmosphere is intensely corrosive. And if you calibrate a maintenance schedule for the worst case airplane, then it's going to be way excessive for the typical airplane. But condition-based maintenance means that you adjust for each individual airplane, that you inspect and you only do maintenance when it's demonstrably necessary. So consider ignoring manufacturers' overhaul and replacement times and replacing or repairing only when inspection shows it to be necessary. This applies to engine TBOs, propeller TBOs, pretty much everything else that has a TBO. These are excellent candidates for using a condition-based approach rather than a fixed timetable. Just as an aside, the engines in my airplane, it's a twin Cessna, has two TSI 0520 Continental engines. Both of my engines are about 190% of TBO right now, and I'm not in a big hurry to do anything about them. I'm pretty sure they're going to get past 200% before I have any good reason to consider tearing them down. Second class of candidates for saying no to are preventive maintenance, scheduled preventive maintenance that's intended to prevent acceptable failures. And when I say an acceptable failure, I'm talking about what the consequences of the failure is. I mean, for example, if an engine fails, that has very serious consequences. We don't want engines to fail. That's a very bad thing. On the other hand, if our number 2 comm radio fails, that's not a big deal. That's not going to ground the airplane. That's not going to prevent us from completing our trip. It's just something we're going to have to deal with when we get home. So we need to think carefully about what the consequences of failures are and deploy our maintenance dollars trying to prevent the serious failures and not trying to prevent acceptable failures. For example, in the Cirrus, which has a highly redundant electrical system with 2 alternators and 2 batteries, the loss of an alternator is much less serious than the loss of an alternator in an aircraft that has only 1 alternator and 1 battery. The maintenance, the preventive maintenance you might do in an airplane that only has 1 alternator is probably overkill for an airplane that has a redundant electrical system like the Cirrus, because the consequences of an alternator failure are not very great. Failures that have only economic consequences, that aren't going to hurt or kill somebody, aren't going to leave you stranded somewhere, those sorts of failures really don't need to be prevented by preventive maintenance. And the optimum strategy for things like that is to run the item to failure. For example, on my airplane, I have 2 vacuum pumps. Since I have 2 vacuum pumps, the failure of 1 vacuum pump is not a serious failure. I can continue my trip and replace the vacuum, the failed vacuum pump when I get a chance. So the logical thing to do with that vacuum pump is to run it to failure. Now the manufacturer says they want us to replace it every 500 hours. But in my mind, that's silly. If I have 2 of them, and failure of 1 of them is not going to put me in any kind of jeopardy, then there's no reason not to get every last bit of life out of that vacuum pump that it has to offer. Third category is that we want to say no to items that are overkill. So, for example, we just had an aircraft whose mags turned out to be a mess, and the shop recommended replacing them with new mags. And we said, no, we don't want to replace them with new mags. We want to send them out to a mag shop and have them repaired. So we never want to replace something if we can rebuild or overhaul it, and we never want to rebuild it or overhaul it if we can simply repair it. Take a look at what those words mean, because the words are very important. The word rebuild means overhaul to new limits by the original manufacturer. So if we rebuild a Slick mag, only Slick can do that. That's now owned by Champion. If we overhaul the mag, then any mag shop can do the overhaul. It doesn't have to be the manufacturer. If we ask for an IRAN, inspect and repair as necessary, that says just do what needs to be done to make whatever it is airworthy. If we say overhaul it, that means do everything in the overhaul manual, whether or not it needs to be done. For example, let's say we had a gyro instrument that was acting up, and we send it into the instrument shop. Most people will send it in and ask for it to be overhauled. We send it in and ask for it to be inspected and repaired as necessary. If you ask for it to be overhauled, the shop has to replace all of the bearings, for example, has to balance the gyro rotor, a whole long laundry list of things that they have to do in order to call it overhauled. If you ask them to inspect and repair as necessary, then all they have to do is fix whatever is not working. And I've seen frequently where the cost to do an IRAN is a tenth of what the cost to do an overhaul is. Now, once in a while, you'll ask them to inspect and repair as necessary. They'll open it up and report back to you that the thing is a total basket case and recommend that you do a full overhaul or you buy an overhaul exchange. But until they open it up, you don't really know. So we always try to avoid overhauling if a repair is all that's necessary. We always try to avoid rebuilding if an overhaul is all that's necessary. We want to get the device made airworthy at the least, with the least possible work and the least possible cost. And what words you use are extremely important. The O word is one of the most overused and costly words in aviation maintenance. Most owners and most mechanics are spring-loaded to the overhaul position. Don't use the word, don't ask for an overhaul unless you really mean it. Most of the time, all we need is to repair something, not to overhaul it. Now let's talk a little about when we don't say no. First of all, we never say no to maintenance that is required by regulation. Airworthiness directives, for example, are required by regulation. We have to comply with them. It's non-negotiable. Saying no to an airworthiness directive is an exercise in futility because the airplane's not going to get signed off. Airworthiness limitations are similarly non-negotiable. Now, older airplanes tend not to have any airworthiness limitations. Newer airplanes like the Cirrus tend to have an airworthiness limitation section in their maintenance manual. And everything in that airworthiness limitation section is required by regulation and must be done. For example, in the case of the Cirrus, the CAPS system, which is the parachute system, requires that the parachute canopy be repacked and the rocket be replaced every 10 years. And it's a big deal. It's about a $12,000 job to do that. But there's no choice. If the airplane is 10 years and 1 day, then it's a paperweight. You can't fly it. This absolutely has to be done. It has to be done on time. There's no grace period, and you can't say no to an airworthiness limitation. We actually had a client last week that turned out that he let his parachute repack expire, and he said, well, I'm planning to do it the next annual inspection. And we said, well, that's fine, but you can't fly the airplane until it's done. And in fact, you can't even fly it to a shop. We're going to have to get a ferry permit when you decide you want to fly it to a shop to get the parachute replaced. And he's probably going to have to take the airplane about an hour's flying time away to get to a shop that is allowed to do the parachute replacement. But the airplane's unairworthy because the chute's timed out. That's an airworthiness limitation. Older airplanes like mine typically have no airworthiness limitations. Newer airplanes like the Cirrus and the Diamond and the Columbia and so on typically will have airworthiness limitations because they were certified under Part 23 instead of the old CAR 3 rules. Finally, the FAA and Part 43 Appendix D of the FARs, this explains what the scope and detail of an annual or 100-hour inspection is. And all of the items listed in that regulation are compulsory at every annual inspection. So, for example, the shop has to do a compression test. It has to cut open the oil filter and inspect it for metal. It has to run up the engine and make sure that all the critical parameters are within specs. And there's no choice about any of that stuff because it's written right into the regulations. So anything that's written into the regs, we can't say no to because the shop isn't going to be able to sign off the annual unless it does all those things. Another area that's a little bit trickier is repairs that the inspecting IA considers to be an airworthiness item. Whenever you get an estimate from a shop on an annual inspection, it's important to have the inspector identify which of the squawks on the discrepancy list he considers to be airworthiness items. In other words, items that he judges to be sufficiently serious that he will not be able to sign off the annual unless those discrepancies are repaired. There are two reasons that an item can be classified as an airworthiness item. One is if the item is not in conformance to the aircraft's type design, and the second is if the IA determines that it is not in condition for safe operation. The first of those criteria is an objective criteria. Normally, when something doesn't conform to its type design, it's because a measurement was taken and the item was out of specifications. For example, brake discs. Every annual inspection, we put a micrometer on the brake disc. If it's a Cleveland brake disc, you look it up in the Cleveland Wheels and Brakes Manual, and it gives you a minimum brake disc thickness. If the brake disc measures less than that thickness, even by 1/1000th of an inch, that brake disc is unairworthy. It's an objective standard, and it has to be replaced. Not in condition for safe operation is a more subjective standard, and that every IA is entitled to make his own determination as to whether he considers something in condition for safe operation or not. But those are the two items that are that make up the notion of airworthiness: conformance to type design and condition for safe operation. And those are the things that will make a discrepancy rise to the level of being an airworthiness item. Now, having said that, some IAs tend to be ultra cautious and tend to call just about everything an airworthiness item. So if an IA declares a discrepancy to be an airworthiness item and you don't agree, go get a second opinion from another IA. And if the other IA says, I think this guy's being excessively anal, then you may have some recourse. If you don't agree that the item is an airworthiness item, but the mechanic is dead set and says I have to repair it or I can't sign off the annual, you always have the option of having the IA sign off the annual with a discrepancy and then go take the airplane to another mechanic and get the discrepancy cleared. And we do that once in a great while. I think out of the 450 annual inspections we've done over the last 3 years, we've deadlocked and had an annual signed off with discrepancies maybe 4 times, maybe 1 out of 100. So it's not very common, but it is a way of resolving a deadlock where you and an IA are in disagreement about a particular discrepancy. At any rate, let's get back to Allan and talk about what we did specifically with respect to his annual. As I mentioned, the total estimate on Allan's annual that came back from the shop and kind of freaked him out when he was in India was $24,730.23. By the time we got done horse trading with the shop, the final total came in about $8,000. Still kind of high in terms of what Allan had been used to. Frankly, you know, he made a pretty serious error putting the airplane in this particular shop without doing proper due diligence. But by the time we got done horse trading with the shop, we wound up saving Allan about $17,000. And let's talk about exactly how we went about doing that and the reason for our various decisions. So let's go back to that discrepancy list and talk about each one of them and what we did. 5-year flex hose replacement, $1,900. We decided to defer that. Although flex hoses really do need to be replaced on a time basis rather than condition, because hoses deteriorate from the inside out. So you can't really inspect the outside of a hose and determine what its condition is. The 5-year duration is based on worst case conditions. We knew Allan had consistently hangared his aircraft, flew it almost every day. It had all sorts of things going for it. So we concluded that it would be prudent to extend the hose replacement for another several years. And then when time came to replace the hoses most likely when the engine was overhauled would be the natural time to do it. We would recommend to him to spend a little bit more money and replace the rubber hoses with Teflon hoses, which eliminates the 5-year replacement cycle. So we deferred that. The fuel drain valve seals, we always decline that stuff. Replacing fuel drain valve seals on a calendar time basis makes absolutely no sense. If the drain is dripping, you fix it. If the drain isn't dripping, you leave it alone. And if it is dripping, the first thing you do is you try to squirt a little shop air up into the fuel drain, which about half the time fixes the problem by dislodging foreign material from the drains, from the valve seals. And if it still drips after you've given it a couple of shots of shop air, then you bite the bullet, take the thing apart, and change the O-rings. And sometimes, especially on the Cirruses, that requires defueling the airplane, so it's sort of a pain. But we don't want to do that unless the drains are dripping. There's no reason to do that on a timetable. Gasculator seals, exactly the same thing. If it isn't dripping, leave it alone. Aileron rudder shock cord interconnect, same thing. We do that on condition. We don't do that every 5 years. The shock cord is typically going to last a lot longer than that, particularly on an aircraft that's hangared. And if the shock cord were to break, it's not that big a deal. The airplane flies a little funny and you say, oh, something's wrong, and you replace the shock cord. So there's no reason to be doing that on a fixed timetable. 500-hour alternator exchange is not only a waste of money, but it's a bad idea. And the reason it's a bad idea is because these alternators, which come from Kelly Aerospace, have had a huge infant mortality rate. They very often fail at very low time in service. And so if you've got one of these alternators that's made it to 500 hours and it's still working, you got one of the good ones. The last thing you want to do is trade it in for another one of questionable heritage. So, you know, the Cirrus has a fully redundant electrical system. Alternator failure is not that big of an event in a Cirrus because there's 2 alternators and 2 batteries. So in a Cirrus, we treat this as a run to failure item. In an airplane that only has a single alternator, we, you know, might be inclined to change it out at maybe 1,000 hours or stuff, but to change it at 500 hours just on a timetable makes no sense at all. And on this airplane, we'll run it until it starts acting up. Same thing for the backup alternator. In fact, the backup alternator is even less critical. It's not even required for VFR flight. It should only be a run to failure item. Makes no sense to be overhauling it on a prophylactic basis. The propeller overhaul, again, the reason that Hartzell proposes to overhaul a propeller every 6 calendar years is because they're concerned about corrosion. This airplane is based in a relatively low corrosive area and is hangared all the time. That's really not an issue. We're real comfortable with running that propeller until engine overhaul time. Airplane's very active, lives in a hangar. It's got every possible thing going for it. Using a worst case TBO recommendation like this is really not appropriate, we think, and so we declined the propeller overhaul. 4-year overhaul of magnetos is completely insane. There's nothing in a magneto that ages with calendar time. The normal procedure is to do a 500-hour tear-down inspection and IRAN every 500 hours. We're very religious about doing that, but to arbitrarily overhaul a magnetos at 4 years makes no sense, and so we declined that item. Same thing with the 2-year main battery replacement. Even the battery manufacturers, Gill and Concord, don't recommend replacing the batteries on time. They recommend doing an annual capacity check and replacing the battery on condition, and that's what we recommend as well. Also, the price quoted on this battery was about twice what you could buy it from at Aircraft Spruce. So we recommended to Allan that that when the battery starts losing capacity, that he buy a battery from Spruce and put it in himself, since battery replacement is something that an owner is allowed to do without getting an A&P involved. So we said no to that one. 2-year TKS anti-ice filter replacement, we always say no to that. It's just silly. I've never seen a TKS filter come out on one of these airplanes that wasn't absolutely spotless, because there's nothing going through it but pure TKS fluid. So what we tell our clients is, unless the TKS system is malfunctioning, or they have some reason to believe that somebody poured a Diet Coke into their TKS tank, just leave the filter alone. It typically will never need replacement. Annual fuel injector nozzle cleaning. We always check the engine monitor data, and of course these Cirruses are instrumented up the gazoo. And if the engine monitor indicates that all the fuel flows are normal and that all the cylinders are running at the same mixture, then there's no reason to be cleaning fuel injector nozzles. Fuel injector nozzles do not get dirty by themselves. They have a very effective solvent running through them all the time, keeping them clean. When fuel injector nozzles give trouble, it's because some mechanic introduced foreign material into the fuel system, and it got lodged in a nozzle and plugs it. So the key to keeping fuel injector nozzles clean is not cleaning them, but not letting mechanics open up the fuel system unless there's an awfully good reason to do it. And by removing the fuel injector nozzles for cleaning, there's a greater chance of making things worse than making things better. So we always decline that unless the engine monitor data indicates that there is a partially clogged nozzle, and we can tell that just from looking at the data. Propeller TKS de-ice boots cracking, that's a condition thing. We asked the shop to take digital photos of the boots. We examined the photos. We determined that the cracks were only cosmetic, that there was no indication that the boots were starting to disbond from the propeller, and so we declined that. At some point, those boots are going to have to be replaced, but not yet. They hadn't gotten to that point. Lower cowling heat damage repair, did the same thing, asked for photos. In this case, the photos made it clear that the damage was pretty serious, and so we approved the repair. But anytime there's a questionable item like this, we always ask the shop to provide us photos so that we can judge whether the repair needs to be done or not. The prop boots were okay. The lower cowling wasn't okay. Wing root fairing caps disbonding. This was another case where we judged that the repair did have to be made. Unfortunately, Cirrus adhered these things with double-sided tape, and when an airplane gets to this age, they tend to start coming loose, and we don't want to take the risk of these things departing the airplane in flight, so we approved the repair. It was not Cirrus Engineering's finest hour to put these things on with two-sided tape. Muffler flame cones warped. We felt that had to be dealt with, but instead of authorizing the shop to replace the mufflers, which is what they wanted to do, we asked them to send the mufflers out for repair, and that was half the cost of what they proposed. Replace the ELT with a 406 megahertz unit. That's not required by regulation yet. The Cirrus has an ACK E01 121.5 unit installed in it. As soon as the ACK's 406 megahertz unit is approved, which should be quite soon now, it will be a drop-in replacement that will cost only about a third of what they proposed. So we suggested that the ELT be deferred for now, and when ACK approves its 406 megahertz unit, we'll put one of those in, and it'll cost a lot less to do that. Miscellaneous paint touch-up. We got pictures. We emailed them to Allan in India. He looked at them. He said, that stuff doesn't bother me, so we declined it. The 50 additional minor squawks, we went through one by one. Most of them we said yes to. They were small things, but we thought they were worth doing. So we said yes to most of that stuff. And the bottom line was, as I said, the total wound up being about $8,000. Still a little bit higher than Allan would have liked, but a whole lot better than 24/7, and we wound up saving him close to $17,000. So this is a pretty good illustration of the process that we go through on literally every annual inspection that we manage. We go through everything in detail. Sometimes we ask for more information. Sometimes we ask for pictures. And we say yes to the stuff we think needs to be done, no to the stuff we think doesn't need to be done or can be deferred. And we typically save our owners a whole bunch of money. Let me point out that this was an extreme case that we just went through. I use this case because it's very illustrative of the kind of stuff that the decisions that we have to make. But frankly, Allan's $25,000 annual estimate was the highest I've ever seen for a Cirrus SR22. We don't typically cut the cost of annual inspections by 2/3, although we do frequently cut them by quite a lot. But certainly reductions of thousands of dollars per year are typical of what you can achieve by using these basic principles. You know, sometimes it's a huge amount of money, like in Allan's case, but most of the time it's a moderate amount of money. But, you know, as Eric Dirksen said many years ago, you know, 1,000 here and 1,000 there, and pretty soon you're talking real money. So this is okay. Let's see. Again, this is not theory. This is stuff that we do every day. I've used these techniques on my own airplanes for well over 20 years. We've managed about 450 annuals in the past 3 years and had tremendous success. If you follow this kind of philosophy and are very clear with your shop as to what you want done and what you don't want done, you can save a tremendous amount of money on maintenance without impacting safety or dispatch reliability, and in most cases actually improving dispatch reliability. A couple of things that you guys might want to be interested in reading. In the January, February, and March issues of the 2010 issues of EA Sport Aviation, I ran a 3-part article on reliability-centered maintenance that goes into this basic philosophy that I've been talking about in very significant detail. So you might want to take a look at that if you're interested. And also in the March 2011 issue, which will be coming up, which will be available in a little less than 2 months, I've got a new column that is called the Waddington Effect. That's pretty interesting. Goes into the research that was done during World War II by the Royal Air Force in terms of the effect of scheduled preventive maintenance and how they drastically, radically improved the dispatch reliability of their fleet of B-24s by drastically cutting back on the amount of preventive maintenance they did. It's a very, very interesting study. It was classified up until the mid-70s, but it's absolutely fascinating stuff. And that'll be coming up in the March issue of EA Sport Aviation. All of the Sport Aviation articles, like the reliability center maintenance ones from January, February, and March, are available online at www.sportaviation.org. In case you don't keep all your paper copies in an archive, you can always get that stuff online. And so, Charlie, at that point, I am pretty much out of stuff to say, and would be happy to entertain any questions if you have any.
All right, Mike, we sure do. Excellent presentation as always. Let's start with Chris's. How can an IA sign off with discrepancies and the aircraft still be airworthy? Can you fly it away?
No. Well, yes, you can fly it away with a ferry permit. But, I mean, we do this all the time. This is not an unusual, well, all the time. We don't do it a lot because usually it's not necessary. But when an aircraft is actually, this is sort of an interesting subject. I'll try to keep it short, but the regs require that you have an annual inspection once every 12 calendar months. An annual inspection can terminate in one of two ways. It can terminate in an approval for return to service, in which case you can go fly it away, or a disapproval for return to service, in which case the IA makes an entry indicating that he has given you a list of discrepancies. Whichever way it ends, the annual inspection is over. You don't have to do another annual for 12 calendar months. If the annual is signed off with discrepancies, in other words, if the IA hands you a list of unairworthy items and makes the required logbook entry, you now have an airplane that is inannual but not airworthy. Now, if that sounds unusual, it's not. Let's suppose you botched a crosswind landing and you wound up with a flat tire. You have an airplane that's inannual but unairworthy. It's unairworthy because it's got a flat tire, and you can't fly an airplane with a flat tire. So how do you deal with the flat tire? Well, you go find an A&P to replace the tire. Or in the case of a tire, you could actually do that yourself because tire changes are preventive maintenance that an owner's allowed to do. Well, an annual signed off with a discrepancy is exactly the same way. If an annual is signed off with a discrepancy or several discrepancies, you now have an airplane that's inannual, but it has it's unairworthy. It's got something wrong with it. So you can have any A&P mechanic correct those discrepancies, and then you can fly the airplane. You never have to take it back to the shop that did the inspection. You never have to deal with that particular IA again if you were having an argument with him. You just, when he ends the inspection and either says it's airworthy or it's not airworthy, his job's done. You pay him for the inspection, you pay him for whatever repairs he did, you take your airplane, you take your discrepancy list, and now he's out of your life, and you just need to find somebody to fix those discrepancies so you can go fly. If there is not anybody on the field to fix those discrepancies, and it's not practical to bring somebody to the field, then you call the FSDO and say, I need a ferry permit to take the airplane somewhere where it can be repaired. And typically, it takes 2 hours to get a ferry permit. You fill out a form, you fax it to the FSDO, and they fax you back a ferry permit. You're good to go. So it's actually no big deal. And like I said, we've done a number of those in the last several years. It's never been a problem. It's obviously not something you particularly want to do, but sometimes there are good reasons to do it, particularly if IA is being unreasonable and is saying I can't sign off the annual without doing something that you really don't want to have done. So does that answer the question, I hope?
I think you got it. Okay, Scott has a question about oil analysis. Should it be done at every oil change or at less frequent intervals based on how frequently you're using your airplane? So, if you're flying 100 hours a year, do you do it 4 times or can you go every other time? What's your suggestion there, Mike?
We do oil analysis at every oil change. You can never have too much data. I mean, the oil analysis is extremely inexpensive. It's like $30 or so, and I would always want to have more data rather than less. So we do oil analysis at every oil change. We use a company called Blackstone Laboratories up in Fort Wayne that we think is probably the best oil analysis lab in the country, and all of our all the airplanes we manage have oil analysis done at every oil change. And by the way, if the oil analysis comes up questionable, we'll typically shorten the oil change interval for a while so that we get more frequent samples until either the numbers normalize or they get bad enough that we feel we need to do something about it.
Okay, Dave has a question. He's got a Piper Cherokee and he wants to know whether replacing the wing walk is a waste of money.
Well, it's a cosmetic thing, so it's totally up to you. If it bothers you, then do it. I would recommend taking it to a paint shop to do that. We have a client who flies a Cessna 310 like mine who decided that he wanted to replace his wing walk as an owner project, and I couldn't talk him out of it. He got about a third of the way into it, and it was a complete disaster, and he wound up having to take it to a paint shop and have it all stripped back down again. So if it's not something you have to do, but if it bothers you cosmetically, I would suggest taking it to a paint shop and having the wing walk done by paint shop.
Okay, and Paul would like you to elaborate on the difference between overhaul and zero time.
Okay, zero time is kind of a misnomer, but I assume we're talking about in the context of engines now. When you when it's time to replace an engine, you basically have three options. You can send the engine to a field overhaul shop. You can exchange it for a factory rebuilt engine, what many people call a factory reman, but that's not the right term. It should be called a factory rebuilt. That's the term that's in the regs. Or if you have way too much disposable income, you could buy a new engine, but almost nobody does that. So the two main options are a field overhaul or a factory rebuild. If you get a field overhaul, you send the engine off to an overhaul shop, and it will come back with your same engine log, but with a new entry in there saying that the engine is zero since major overhaul. If you exchange your engine for a factory rebuild, you return your engine logbook with the core engine that you send back to the factory. They send you a factory rebuilt engine with an empty logbook, a logbook that has only one entry in it that says this is a rebuilt engine and it's zero time since rebuilt. The fact that a factory rebuilt engine has a so-called zero-time logbook or an empty logbook is because the process that takes place at the factory is different than the process that takes place at a field overhaul shop. When you send your engine to a field overhaul shop, it retains its serial number, and the engine that you get back from the overhaul shop is legally the same engine that you sent to the overhaul shop. Now, it has a whole lot of new parts in it, and it has some reused parts in it, but it's legally the same engine that you sent them. But when you buy a factory rebuilt engine, the engine they send you is an engine that has legally never existed before. Basically, the process is you send a core back to the factory. First thing they do is rip the data plate off of it and destroy it. At that time, the engine ceases being a legal engine. They then take it apart. They throw out all the stuff that can't be reused. Actually, they don't throw it out. They send it to a metal recycler. The stuff that can be reused, like the crankshaft and the case halves and so on, some of the gears, go through all sorts of inspections and so on. And then they wind up in a big bin of crankshafts and a big bin of case halves and a big bin of gears and become part of somebody else's factory rebuilt engine. But they lose their identity. They no longer are associated with the engine that you sent to the shop. And then when the factory rebuilt engine is completed and ready to ship, the last thing they do is they take a brand new data plate off the shelf and they stamp a serial number on it, which has never existed before, and lo and behold, an engine comes into existence that didn't previously exist. And the serial number will have an R at the end of it saying it's rebuilt, and then they ship the engine to you. And the reason that the logbook has nothing in it except just this one entry is because there's no history on any of the parts that went into this engine. Some of them are new, some of them are reused, but they have no idea where they came from or how much time's on them because the parts get de-identified in the process. All they know is that the parts are airworthy. but they don't have any idea how much time's on them. So a rebuilt engine doesn't have any time carried forward because the time on the components is lost in the process of rebuilding. A field overhaul engine, the overhaul shop is required to segregate the engine you sent them from all the other engines that other clients send them and not mix and match parts. And the engine you get back is the same legal engine with the same legal serial number that you sent them, and its time is carried forward. But the fact that a factory rebuilt engine is quote unquote zero time doesn't mean it's any younger or that it has any fewer reused parts or any more new parts or anything like that. The reason for the zero time on a factory rebuilt engine is simply that the process is different and that the factory is allowed to de-identify core engines that come back to them, but a field overhaul shop isn't. I guess that answers that.
Okay, Ralph would like to know, can I change my own alternator on my Piper Dakota and the regulator? Mechanic would not sign off since he did not do the work.
Well, the answer to that is you cannot approve an alternator or regulator change yourself, because assuming you're not an A&P yourself, because it is not one of those items in Part 43, Appendix A sub C that is considered to be a preventive maintenance item that an owner is allowed to do on his own recognizance. You can do anything to your aircraft if an A&P is willing to supervise and sign it off. There's no limit to what you can physically do. But you need to have an approval, a signature, by an authorized person under Part 43. The reg is 43.3 that defines who's allowed to sign off on an airplane. And except for the 36 items listed in Part 43, Appendix A sub C that are preventive maintenance items that you're allowed to do yourself, like oil changes and filter changes and spark plugs and tires, and there's a whole long list of stuff that you're allowed to do on your own recognizance. The alternator and the regulator are not on that list, so you are not allowed to approve that work yourself. You could do it yourself if you arrange with an A&P to supervise your work and sign it off. And supervise doesn't necessarily mean that he hangs around while you do it either. Supervise is whatever the mechanic feels that he needs to do. So frequently supervise means, sure, go ahead and do it and call me when you're done. I'll inspect your work and sign it off. And that's perfectly legal if the mechanic is comfortable with it. It sounds like this particular mechanic isn't comfortable with it, but you shouldn't ever expect a mechanic to sign off your work without first prearranging with him so that he can supervise your work to the extent he deems necessary. And some mechanics are happy with, call me when you're done, and other mechanics aren't. It's a totally individual thing, and mechanics have tremendous discretion in that regard. But you can't sign it off yourself.
So I guess the thing to take away from this, if anyone's thinking of a restoration project on a standard category aircraft, you better coordinate it with whoever the mechanic is that's going to ultimately sign off all the work, correct?
Right, right. The basic rule is never surprise your A&P. A&Ps don't like to be surprised. If you pre-coordinate it, many A&Ps will just knock themselves out for you and will give you all sorts of latitude. But if you do something without authorization and then ask them to clean up the mess, they typically aren't real happy about that.
Okay, a couple of follow-on questions that we've had about the list of owner-performed maintenance. Is that listed in 43, Mike?
Yes, it's 43 Appendix A sub C. And there are about 36 items in that list, of which 24 apply to airplanes. And the other dozen apply to things like balloons and helicopters and other kinds of things. But there are about 36 specific tasks that the owner of an aircraft who has at least a private pilot certificate, unless it's a light sport aircraft, in which case he only has to have a light sport pilot certificate, is allowed to do on his own airplane. And they're specifically enumerated in Part 43, Appendix A sub C, and you can pull that stuff up online and see what the list is.
Okay, Jen has a question. Do you recommend the use of AvBlend, CamGuard, or both at each oil change?
I strongly recommend the use of CamGuard. I have used it in my own airplane for almost 4 years now. Done a lot of research on it. It's excellent stuff. We now recommend it to all of our Savvy clients, and probably 90% of them are using CamGuard. We've seen very dramatic improvements in oil analysis. I do not recommend AvBlend. I do not disrecommend it either. When AvBlend first came out, and AvBlend is basically a repackaged version of an old automotive additive called Lenkite. But when AvBlend first came out, we ran a fairly extensive test in several light twins where we treated one engine with AvBlend and we left the other engine untreated. And we did oil analysis on those airplanes. And we never could see any difference. You could not look at the oil analysis and tell which engine was treated and which was untreated. So my best assessment is that AvBlend doesn't really do anything useful. I've never seen any evidence that it does anything harmful. So if it makes you sleep better at night, I wouldn't discourage you from using it. It's just that I've never seen any indication that it does anything good. On the other hand, we've done extensive oil analysis tests with CamGuard, and I started that on my own airplane, and the results have been very, very impressive. So I'm a big fan of CamGuard. I'm kind of an agnostic on AvBlend, I guess you'd say.
Okay, three viewers have chimed in with questions related to, do you have a preference about a factory rebuild or a field overhaul?
It's a case-by-case situation. We've done a lot of engine changes on our clients' aircraft. Sometimes they're field overhauls, sometimes they're factory rebuilds. There are a number of considerations that have to go into choosing which to do. We normally will go with a factory rebuild if the engine is a poor field overhaul candidate. For example, we had one airplane that threw a rod through the side of the case. The case was trash. It couldn't be reused. If we had a field overhaul, there would be a very significant upcharge for a new crankcase. The factory will usually take most engines, even if they're in very bad condition, and give full core credit. Another example, the crankshafts on most Continental engines were changed from an air melt process to a vacuum arc remelt process, just a different kind of process of the steel. And there's an airworthiness directive requiring that anytime you split the case of an engine that has an air melt crankshaft, you have to replace it with a VAR crankshaft. So again, now most of those air melt ones are out of the system by now, but if an engine had an air melt crankshaft, it would not be a good candidate for a field overhaul because you'd have to buy a new crankshaft, and that would add $8,000 to the cost of the overhaul, whereas TCM will take an air melt core back without any upcharge and give you a factory rebuilt engine with a VAR crank. So that's one consideration, is whether the core engine is a viable candidate for field overhaul, or whether it has some very expensive thing wrong with it that would result in a field overhaul costing a whole lot more money. The other consideration is has to do with downtime. If you factory overhaul your engine, you're going to have to down the aircraft, pull the engine out, crate it up, send it off to the overhaul shop, have it overhauled, which is usually roughly a month to turn around, then have it shipped back and then reinstalled. And so realistically, the airplane's going to be on the ground for about 60 days. With a factory rebuilt engine, there still is typically going to be a multi-week wait for the engine because they don't keep them in stock. But you can order the factory rebuilt engine and then keep flying the old engine, assuming the old engine hasn't cratered somehow. And whenever the new engine shows up, you can then down the airplane, pop out the old engine, put in the new engine, you're back in the air, and then the old engine at the shop's leisure gets sent by slow freight back to the factory as a core. So you can often be down for considerably less time with a factory rebuilt engine. So that's another consideration. A third consideration is the fact that if you have a field overhaul done, you can pretty much get the shop to build the engine up any way you like. For example, we tend to like ECI nickel carbide cylinders better than TCM factory cylinders, particularly for airplanes that fly irregularly and live in corrosive environments, because the nickel carbide cylinders won't rust. You can't do that with a factory engine. You can't order a factory engine from TCM and say, oh, by the way, we don't want your cylinders, we want ECI cylinders. But on a field overhaul, you can do anything you want. When I had my engines overhauled in 1990, TCM had just changed from forged aluminum pistons to cast steel belted pistons that weighed a whole lot more. And I just didn't like the idea of that huge increase in reciprocating mass. So I had the overhaul shop use old style pistons rather than the current TCM pistons. If I had ordered rebuilt engines, I wouldn't have had a choice. And there were a whole bunch of other things when I had my engines overhauled that I did differently, that I elected to do differently than what the factory was doing. So again, when you field overhaul an engine, you can pretty much have the shop do anything that you want them to do. If you want the case halves powder coated in pink, you can have that done. I don't recommend it. But you pretty much can do anything you want. If you want a slick harness instead of a TCM harness, if you want, you basically have all sorts of latitude with a field overhaul, where when you order a factory engine, you get the factory engine du jour, whatever they happen to be shipping that week, and you really don't have any real options. So I think that pretty much covers it.
Okay, John asked, did I hear you right that you don't recommend the constant speed prop overhaul until TBO on the engine? My bird is hangared and gets 40 to 50 hours a year on it. Hartzell's recommended overhaul is 72 months for my prop.
Well, again, let's be clear. I didn't say I don't recommend the TBO. What I said was that the TBO, like all TBOs, is a worst case TBO for the worst case airplane, and that in my mind, if the airplane has a bunch of things going for it, like being hangared, like flying regularly, that sort of thing, like living in a not terribly corrosive environment, that it's perfectly acceptable to push the TBO. Interestingly enough, last, when was it? Sometime, I think last June, I happened to be in Piqua, Ohio, at the Hartzell plant, and I had the opportunity to sit down with the head of product support for Hartzell, and I explained to him what our policies were in terms of recommending prop overhauls, and he basically said, off the record, I have absolutely no problem with what you're doing. I think you understand exactly what the right factors are. He said, on the record, the lawyers would kill me if I ever agreed with you. But he said, off the record, that's. He says, I agree that that what you're recommending to your clients is perfectly reasonable. So I thought that was a fairly good vote of confidence on that.
Okay, Paul'd like to know what he should look for in choosing a shop to overhaul an engine.
What you should look for. Well, not sure how to answer that. I guess the best answer I would have is, if you want to drop me an email, I'd be glad to send you a list of a dozen shops that I'm real comfortable with. I don't think we want to put that on the webinar, but there are a lot of shops there, shops out there. Some of them are better than others, and I would be glad to provide some suggestions to you if you want to drop me an email. Do I have my? Oh yeah, I forgot.
There you go. I was going to ask you if you had contact information.
That was supposed to be up all along. Sorry about that, guys.
Okay. James has a question about the new ELTs. What maintenance is required for a 406 ELT? Is it different than the old style?
Well, you know, that's a really good question, and I am embarrassed to say I don't know the answer. What we would have to do is look at the instructions for continuing airworthiness. There are no regulatory changes. In other words, what's written into the regs has not changed. But the new ELTs, each one of them will come with instructions for continuing airworthiness. And to be honest, I haven't looked to see what those instructions for continuing airworthiness say, and more important, how they're structured. Because the rules are that if something is in the ICA and written up as an airworthiness limitation, then it's FAA approved and compliance is compulsory. If it's in the ICA but not in an airworthiness limitation section, then it's a recommendation, and we don't have to do it if we don't want to. So that's a really good question. I need to take that as a homework assignment, and I'm embarrassed that I don't have the answer right off the top of my head.
Okay, Bob has a question. How do you make the subjective calls on airworthiness items, especially on older airplanes? For example, what will lead you to decide it's time to overhaul the engines in your aircraft?
Well, that's an excellent question. When you go to a condition-based approach as opposed to a time-based approach, and TBOs are time-based, first of all, you're basically taking on the obligation to use all of the condition monitoring tools at your disposal. And for engines, we have a lot of really good tools. Obviously, oil filter inspection, oil analysis, bore scope inspections, engine monitor data analysis, monitoring things like oil pressure trends and so on. And all of those put together give us a very, very good feeling for what's going on. Occasionally, we'll wind up having to pull a cylinder for some reason. Let's say the exhaust valve is problematic. And that gives us just a wonderful opportunity because it opens up a big hole in the side of the engine, and we can stick our head in and look around and actually take a look at what the bottom end looks like. And we can do things like, you know, wiggle the connecting rod and get a really good feeling for the condition of the big end connecting rod bearing. And if the big end connecting rod bearing is in good shape, we can be pretty sure the main bearings are in good shape. But that's really the approach, to use just this large collection of tools that we have for assessing condition. And if we put all of that information together, we can have we can feel pretty confident that we know what's going on inside the engine. It's interesting that, and this is a topic for a different webinar, I don't really want to get started, but we've done a lot of research on engine failures, and the overwhelming majority of engine failures occur in the first 200 hours after an engine is built, rebuilt, or overhauled. And there's almost no evidence that the failure rate increases in geriatric engines. So the biggest risk by far of having a catastrophic engine failure is right after you have major overhauled the engine or right after you've installed a factory rebuilt engine. And so if you want to be worried about the engine, that's the time to be worried about it, when it's young, not when it's old. And I've got a lot of research and a lot of good PowerPoint slides and stuff about that, and maybe maybe Charlie, sometime we might want to do a webinar on that subject, but it's really, really quite interesting.
I think that'd be an excellent topic, and I'm going to hold you to it. Mike, with that, we've already hit the end of our allotted time, and I just want to say thanks to you for taking time to do this. As many, or some of you may know, this is a repeat. We had a lot of technical difficulties on the first one. This one's gone pretty smooth, from my end at least, so I hope everybody had the same experience that I did. But thanks for taking the time tonight, Mike, to share your knowledge with everybody. You're just a wealth of knowledge. I learn something every time I tune into your presentations or read your articles in the magazine, and you're just a real asset to the community. So thanks for taking the time tonight, Mike.
My pleasure, Charlie. Let's do it again soon.
Absolutely. And thanks everybody else for tuning in. And with that, I'm going to sign off and have a great evening.
Night, everybody.